Welcome to, as we entitled it yesterday afternoon, Thinking Week. Okay? Today is Thinking Week, this week is Thinking Week here in the pre-calculus, because just when you thought you had all of the methods and ways and could understand all of this trig stuff, we go and we spin it on its head. Okay? Because today we're going to start with navigation. Okay? Now, before I start with navigation, let me just remind you that you have a quiz this week, Friday, which is actually the 15th, not the 14th, as I wrote down yesterday. So you have a quiz this week, Friday, and you have four homeworks that are due if you are an 80%er. Okay? It is your job to go look and see if you are an 80%er or not. You have the purple worksheet that you got last week's one day, I believe. You'll get the salmon worksheet today, and you'll get the yellow worksheet on Thursday, and there's a book assignment and that's actually, the book assignment is on top of the salmon colored worksheet for today. Okay? So, navigation, bearing, all that fun stuff. Okay? Now, when we're talking trig, when we are talking trig, found it. When we're talking trig, we're talking that we've got 0 here, and positive angles go that way, and negative angles go that way. Right? And then we'd have 90 up top, 180 or pi way out to the left, and 270 straight down, or 3 pi over 2. Right? Okay? The problem is that with navigation and bearing and heading and that fun stuff is that north is 0 degrees. So now, whenever you're dealing with bearings and headings, now north is your 0 degrees. Which means south would be, how many degrees is straight south? 180. Okay. Okay. And then I remember it because it spells out the word we, and we are going on a journey. Okay. The positive direction here is east is 90 degrees and west is 270 degrees. So positive angles are not drawn counterclockwise like in trig. They are drawn clockwise. In navigation. Okay? Thinking. Okay? All right? So, if I had a 53 degree angle, I don't even know why that's there, because it doesn't have to be, because you can already see it. If I had a 53 degree angle based off of my navigation, my 53 degree angle would be right over here, because this would be 53 degrees. 195 degrees would be down here, because I would have to come 90, and 90 would be 180, and then 15 more to get me 195 degrees. 300 degrees, I would have to start at due north, and I would go 90 and 90 and 270, and then I'd have to go 30 more to be 300 degrees. A 127 degrees, I'd have to go 90 and then 37 more to go there. Okay. Questions on bearings, headings, all that fun stuff. Cool in the gang. So let's jump right into a problem. Okay? The problem says a speedboat is traveling at a speed of 40 knots. Let's take a pause here to make sure that we understand what a knot is. Okay? It's not how currently my shoelaces are tied. Okay? What is a knot? Anybody know what a knot is? Any mariners out there?
I know that a notch is a unit of velocity, but I'm not sure the exact.
It is a unit of velocity. It's a speed, if you will. Okay? Nautical miles is a distance. So a knot would be nautical miles per hour. Yep, it's the quote unquote water speed. Okay? Because there's no mile markers out in the middle of the ocean, they use knots. Okay? So it's nautical miles per hour. Does anybody know what a nautical mile is? Anybody? So you take the globe. I can click right here on this wonderful thing. So what you do is you take the globe and you cut it, or you take the Earth and you cut it in half at the equator. Okay? That's going to give you a circle that looks kind of like this Alexis thing going on here right now, or this Google thing. Okay? That's going to give you a circle if you look at it in 2 dimensions. Okay? So then you take that circle and you divide that circle up into 360 degrees. Okay, so you 1/360th of it. Then you take each degree and you divide that up into 60 minutes. Okay? And a knot is the distance that you have to go for 1 minute of 1 degree around the circumference of the Earth. Okay? So it ends up being 1.1508 land miles is a knot, or 6,076 feet. Okay? That's how it is a knot. Okay? Okay? So to travel around the equator, you'd have to travel 2,100 or 21,600 nautical miles is the circumference of the Earth. Okay? So that's what a nautical mile is. And a knot then is nautical miles per hour. Okay? Okay? So, a speedboat is traveling at a speed of 40 knots from Fort Lauderdale. So let's say that this over here is Fort Lauderdale, because it is. Okay? It's actually a little high for Fort Lauderdale, but that's okay. Okay? All right. Then it's on a course that then it changes course. So let's tap the brakes here and let's go a course of 65 degrees. So in which general direction, up and left, up and right, down and left, down and right, is 65 degrees in terms of headings? Up and right? Okay. I would go with up and right. So if I would go like that, then this angle in here would be 65 degrees. Okay? So it travels on that course for 2 hours. How many nautical miles have I gone in that 2 hours? 80, because I'm traveling at 40 nautical miles per hour for 2 hours. Tells me that that side is 80. I've traveled 80 nautical miles. Then we have a course change. Okay? And our course changes to 155 degrees. Now 155 degrees would be down and to the right. So this angle right here is now 155 degrees. And we travel along that path for 4 hours. So how far or how long is that green segment? That's 160 nautical miles. Okay. It is asking us to determine the distance and bearing of our boat. So our boat is now right there. It's asking us to determine the distance and the bearing of our boat from Fort Lauderdale. So we need to find this side length here, and we need to find that bearing from Fort Lauderdale. Okay? Well, let's do some thinking. Okay? All right? If this blue angle right here is 65 degrees, what is this angle right there? It is also 65 degrees. Okay. The east-west or the west-east line from Fort Lauderdale and from where we met the turn are parallel. Cut by a transversal, those are alternate interior angles. Actually, it would be the north-south line is what we're going off of in both of those cases. Okay. All right, so now let's talk green. If this angle right here, this big angle, is 155 degrees, what is this angle in there? It's 25 degrees. So if I have a 65 degree angle and a 25 degree angle that make up one angle of a triangle, what is that big angle then of the triangle? That's 90. Hey, that helps out. Right? Because now I have a right triangle. All right? So let's break out said right triangle. Got a right triangle. It's got a leg that's 80. It's got a leg that's 160. And we need to find that side. How am I going to find that side of that triangle? Pythagorean theorem. Love it. So 80 squared plus 160 squared is going to equal x squared. 80 squared is 6,400. Bless you. 160 squared is 25,600. Add those two together and you get 32,000 is equal to x squared. Now if I take the square root of that, I get 80 times the square root of 5 if I'm being exact, or if I am rounding it, I get 178.885 nautical miles. So that is my distance from Fort Lauderdale. It also asked me to determine the bearing from Fort Lauderdale. Well, here's my boat. Here is Fort Lauderdale, right? So I'm probably going to need to find that theta at Fort Lauderdale. How would I go about finding that theta at Fort Lauderdale in that triangle? Inverse tangent. So I would set it up as the tangent of theta is equal to the opposite side over the adjacent side, which then would give me theta here is equal to the inverse tangent of 2. And if I find the inverse tangent of 2, that tells me that theta here is equal to 63.4349 degrees. But again, I have to do some thinking. So I'm going to blow up that Fort, oh, that's a bad one. That was just bad. We'll make it look nice and good. Whoa, maybe not. Come on now. I'm going to blow up that angle, the angles that were going on at my original Fort Lauderdale. Okay? So at Fort Lauderdale, we had a blue line coming out this direction, and we had a red line coming out in this direction. Okay? What we just found was this theta right here. This whole entire angle we just found to be 63.4349 degrees. In our original problem, we said that this angle up here was 65 degrees. Okay? So, knowing that, and knowing the fact that the bearing is going to be this entire angle right there, I'm going to have to add those two angles together. So my bearing is going to be 65, my original degrees, plus the degrees that I just found, 63.4349 degrees, tells me then that my bearing here is equal to 128.4349 degrees. Questions on that? Yes, ma'am. On my original diagram, the theta that we found would be, let me go with this color, would have been this angle right there. the bearing, because then we have to add the 6, because remember, bearings come off of north, which is now our 0 degrees. So we'd have to come off of north and come all the way down here. So that's that 65 plus that angle theta that we found. No problem. Okay. What I would like you to do now is I would like you to try. I don't expect you to be successful, but I would like you to try number 6. Just a quick spot check, just to kind of, get you going along the right direction. You've got 2 points on shore that are 300 feet apart. Okay? So that's your initial setup. Go from there. Now, he give you a couple of extra tidbits, side notes, if you will. Okay? 2 things. 1, a picture is going to be extremely helpful in all of these word problems. Okay? That's tidbit number 1. Tidbit number 2, it is going to be helpful for you to carefully read the problem multiple times to make sure that you understand. Okay? For instance, some of you probably glossed over the fact that the bearings of the boat from the 2 points on shore. So the angles are from our shoreline angles, not boat angles. Okay? All right? That's a kicker, is knowing that one. Okay? So the angles that we're talking about here are angles from the shoreline to the boat. From the shore to the boat. And the boat is just kind of anchored out there, just having a grand old time fishing. Okay. All right? So that's kicker. Now, let's do some thinking. We've got a 240 degree bearing and we've got a 260 degree bearing. Okay? By the way, you know what the difference between bearing and heading is? There is. It's just a technicality, though. Bearing is me looking at something. Heading is me traveling in that direction. Okay? That's the difference between bearing and heading. Okay? So this is a bearing because I'm standing on shore and I'm looking out at something. If I was in the boat heading somewhere, that would be a heading. Okay? All right? So, which one is my 240 degree one? The blue? The top one is 240 degrees? Okay. Logically, I would agree that the top one here is 240 degrees. That means the bottom one then would be my 260 degree one. If you think about it, that triangle got compressed. The boat didn't move, but that angle, that acute angle off of the shoreline and the line of sight to the boat got bigger. So the bottom angle has to be the bigger one. Okay? You know that this top angle in here, yes ma'am, is 60 degrees. And you know this bottom angle in here is 80 degrees. Okay? It is asking, this question is asking for the distance from the boat to the shore. It's asking for that, right? Now this eerily reminds me of yesterday's hot air balloon one. Okay? So I am going to set this as y in there, that distance as y in there, and then I am going to break out 2 different tangents. So the tangent here of 60 degrees is equal to the opposite side x over my adjacent side y plus 300. Then the tangent here of 80 degrees is equal to the opposite side x over the adjacent side of y. If I rewrite these, then this would be y plus 300 times the tangent of 60 degrees is equal to x. And this one would be y times the tangent of 80 degrees is equal to x. Knowing the fact that the x's are equal, I can set those two equal to each other. Y plus 300 times the tangent of 60 degrees is equal to y times the tangent of 80 degrees. Distributing, y tangent of 60 degrees plus 300 tangent of 60 degrees is equal to y tangent of 80 degrees. What I did there is I distributed this tangent into my set of parentheses. Then I have y's on either side of the equation. Let's get them on the same side. 300 times the tangent of 60 degrees is equal to y times the tangent of 80 degrees minus y times the tangent of 60 degrees. Then let's factor out a y. 300 times the tangent of 60 degrees is equal to y times the tangent of 80 degrees minus the tangent of 60 degrees. Then let's divide both sides by that parentheses to give us what y is equal to. So 300 tangent of 60 degrees divided by the tangent of 80 degrees minus the tangent of 60 degrees is my y. Right? But I want x from way back in my problem. So I'm going to bring down that y, that y times the tangent of 80 degrees equals x equation that we had right here, okay, when we solved in that green triangle. And so I'm going to take this black y, this black y here, and I am going to multiply it by the tangent of 80 degrees on my calculator. And that's going to give me x. Okay? So when I type that into my calculator, 300 times the tangent of 60 degrees, divide that by the tangent of 80 degrees minus the tangent of 60 degrees, hit equals, then multiply that again by the tangent of 80 degrees, I get the fact that it is 748.086 feet offshore. Y should equal, I never did plug it in correctly because I knew I was going to use it again based off of the hot air balloon problem. But if you would divide that, dear, by the tangent of 80, you'd get what y is. Okay?